Hello everyone. So in this lecture we'll talk about the blockchain, what is it exactly and how it is different from the other technology. And if you are very well aware of blockchain and completely understand everything, then you can skip this lecture as well if you want. But I think it's good to go through the entire lecture to get the gist. So what is blockchain exactly, and and how it is actually different from other type of technology? So blockchain at fundamental level is a data structure which is being stored on a peer-to-peer network or in a decentralized network. When we say peer-to-peer network or a decentralized network, it means that it is a data structure which is being stored on a multiple computers at the same time in such a way that all the computers are connected to each other, forming a network, right, forming a small mesh, right. So but of course you might be thinking that what is data structure and what it exactly means. So data structure is nothing but an arrangement of data in such a way that it can be read and write very easily by external programs or softwares or whatever you want. So it's nothing but an arrangement of data in the computer memory. In real life you can imagine anything as a data structure. You can call a PDF a data structure. You can call an Excel sheet, MySQL table, a binary tree. If you are aware of the data structure computationally, then binary tree is also called a data structure. Then array, you might have seen the array in your C language or programming language whenever you have read the programming. Then array are also a data structure. So there are multiple things. So now we when we talk about the blockchain, so blockchain is actually a sequence of connected blocks where the each block contain the multiple entries which are known as transaction. So in this case, where which I can see, which I can show you right now here in the screen, if we'll understand that just imagine a book, right? A book has a, let's say, 100 pages. So then all the 100 pages are connected to each other because of the numbers, right, because of the numbering at the bottom, right. So using the numbering at the bottom you can easily identify if that particular page in the PDF has been deleted or not, because the sequence will be missing. Then, right, there will be a a particular mismatch. Let's say, after, suppose someone has deleted a page for 15, then for after 14 you will see directly 13. Then you can easily identify, okay, 15 number is missing, right. So that means that if you can consider a page is equal to block, then it sees that, okay, all blocks are connected to each other using page numbers. That's fine, that understood. But the question is, what if we alter a particular letter in a page? How will you identify it? Is there a computational method using which you can identify it very quickly if the particular page has been tempered or altered in some way? So the answer is, you can do it using the blockchain kind of concept. So as I have already told you that we can imagine the blockchain as a sequence of pages, right, where the each page is connected to each other using the page number, right. It is easy to detect a page number and easy to arrange the pages and identify the suspicious activity if it is there. That's why the page numbers are important in legal agreement and documents. But if the content has been altered, then it will be very difficult to identify if that is being done without actually breaking the chain, right. So idea is simple. Whenever you are actually creating a page number of a particular page, just try to add the digest of the entire page into the page number, right. So that, and then create a page number which will be referenced to the next block, right, like this, for example, right. Let me say, in this example, let's say, for example, let's say if the this entire block will be the digest of this entire block will be created and will be kept in the bottom, and then which will be merged with the page number, and then the digest of that will be put in the beginning of the block. So in this way, if this will happen, then if you change even one letter in this particular page, then the the connectivity will break automatically, right. And then you can easily detect that from this block onward, since the connectivity is not there, you can easily identify this, that this block has been tempered and altered, which is not possible with the MySQL, right. So now, for example, in this case, let's say if you have a page 0, the page 0 has all the pages, right. Page 0 has all the pages, and at the bottom of the page 0 you will actually create a digest of the entire page, right, and then merge it with the existing page number, and then create a new page number using that, right, and then build another page on top of the previous page, right, in such a way that the previous page number will also be kept in the new page. So all pages will be connected like this: block this built on top of this, then block this built on top of the previous block, then block this built on top of the another previous block. So this way all blocks are connected and represent the fingerprint. So when we talk about the digest or the signature, it's a actually computational algorithm which convert any size of data into a fixed length of string which is unique, and it is not possible to regenerate that string again back. So, so as you can say in the real life case, each block is built on top of the recent block and use its previous block's content as a signature inside the new block. So building a block and adding it in the blockchain is the task of the miner node, right? So as you might be aware that what are miners? So miners are someone who add the new block, right? By actually, uh, you know, uh, entering some transactions into that block and putting it into the blockchain. That's called a mining. In public blockchain, it is made computationally difficult to add a block to prevent attacks and the hacking. So that's simple. If you are actually able to create one block after investing some computational power and time and money, then if somebody has to fake the entire blockchain, he has to invest a lot of money and power. So that way actually cryptographers secure the blockchain. So we'll talk about this further when needed in the Ethereum concept also. So miners actually try to guess a number. So you might be thinking what exactly miners do to actually mine the block. It must be easy, right? But no, that's not easy. So miners actually try to guess a number in such a way that if it gets crunched with the most recent block's fingerprint, then it will create a new fingerprint which will be less than the most recent block in the blockchain. Computationally it is highly difficult to do it, and it also varies and actually depends on the difficulty of the blockchain, which actually keeps changing on time. So it takes actually time and computational power to add blocks in the blockchain, right? And hence there is some reward, because if somebody is investing their computational memory, time and everything, then there should be some reward in exchange of their computational power. In current world, this is currently 25 bitcoin, which keeps halving every 4 years, right? So currently it's 25 bitcoin, earlier it was 50 bitcoins. Next is that the private blockchain can choose other methods to add a block. They can they can trust the miners using the contracts, legal obligations and agreements. So that's how the private blockchains completely behave differently than the public blockchain. So this is how a simple, the block looks like in a blockchain. So here is the fingerprint of the previous block, which will be kept in the new block's header. Then the new transactions will come, and then the reward will come, and then all these things, a previous block fingerprint, these new transaction, and the reward will be crunched together and will be added as a bottom as a new fingerprint, which will be again kept to the new location. So this way, the all blocks gets connected to each other. So here's the summary. It is a decentralized distributed ledger or a data structure where data is being stored inside the blocks in form of transactions. It removes the dependency on the trusted third party for recording the data in the blocks, because there is a peer-to-peer network. All the computers together decide based on the consensus algorithms whether to record certain data or not. So that's why there is no trusted third party or centralized server needed. Like in public blockchain, more complex algorithm required to avoid the malicious activities, which is not the case here in the private blockchain case. Since each block is built on top of the previous block, immutability has been achieved, right? Because if you break something in the previous history or the past blocks, the all upcoming blocks will be invalidated and will not be linked together. So that will create a problem and will easily will gives a very easy method to identify the any tampering into the blocks. So it's very difficult to fake a block, very easy to detect a fake block. So that's how the immutability has been achieved, right? So because it's a consensus based decentralized network, it's not easy to hack every computer on the internet and then secure the or to hack the blockchain. That's why it is considered as safe. This all exists in memory of computer, so just a program running over the in a computer, that's it. And each participant in the blockchain contains the most almost the same copy of the blockchain. Just last few blocks might differ based on the forking and the branches of the blockchain, which keeps running and continuing following the longest chain in the block, that we'll talk about later on also. So that's it for this lecture. If you have any questions, please ask.